Hello everybody, thank you a lot to come from at FOSDEM. Today we'll see a presentation about storing metrics at scale with Gnocchi. Thank you.
Thanks. Hi everyone. So today I'm going to talk to you about Gnocchi, which is a time series database. First, I'd like to introduce myself briefly. So I'm Julien. I work at Shredat for a bit more than a couple of years now. I mainly work on OpenStack, which is written in Python, as you might know. So OpenStack is a cloud computing platform for those who don't know. So you're supposed to run a lot of virtual machines and a lot of computers. I've done a lot of free and open source stuff since 15 years now. And a lot of Python these last years. So today I'd like to talk about what Gnocchi is and why we created it, because I don't like to create projects for nothing. How does it work, what it does, how it does it. It's in Python, so it might be interesting for you guys. And how to use it, because, well, you can use it in Python too, so it might be interesting. So what's it? So it's a time series database, so I can imagine most of you knows what a time series is, but it's basically storing a suite of points composed of two things, a timestamp and a value, and then you can create nifty graphs and nifty charts to show things. So the first value in a time series is timestamp. There's nothing very surprising, and the other value is going to be anything you want to meter, so it would be the temperature in a room or the CPU usage of a computer in our case. So in the context of the OpenStack project, which is a scalable cloud platform, at least in theory, we needed something to store metrics of a lot of virtual machines, volumes, networks, everything you can imagine in infrastructure. So we need something which was scalable, which is not something you can find easily. A lot of software others are not designed to run on a lot of computers. So that's something we wanted to find. We wanted something that was easy to use. So everything in OpenStack is controlled by API, and so we wanted a time series database that was programmable against, something you could use to write programs, query, and do things like retrieve statistics or things like that. And something very easy to operate. So what does that mean? The OpenStack stack is mainly in Python and uses pretty simple technologies that we know for a long time, like SQL or messaging queues or things like that. There's no big things like Hadoop or Cassandra or things based on in Java, for example, and nobody wants to install that in our world, at least. So what was the blocker for us? Because we took a look at existing solutions, such as Graphite, which is deployed a lot, but it's not scalable. Some of it is in Python, and I wrote a nice blog post a couple of years ago about how not to write Python. You can take a look at the code from Graphite. It's pretty reliable. It's not modulable. InfluxDB was a new cool kid in town. It's written in Go, but it doesn't work. It has gone proprietary in part last year, so it's not really open source anymore, and it doesn't scale. OpenStack is another solution. You need to set up Hadoop. You have new things since a couple of years, like Prometheus, which I think uses Cassandra, which is not an option for us too, because nobody wants to set up Cassandra on your Hadoop nor anything like that. So we had to create something from scratch, which we call Gnocchi. It's part of the OpenStack project, but it's really not part of OpenStack in terms of dependencies. It works standalone by default. It's like a standard database. So we designed it in a way where it is easy to install because you can use pip to install it, which is a very big difference in a lot of other software. It's written in Python, it's free software. We also put, which something not you don't see very often, very strict documentation policy, where we force developers to write documentation before merging anything, which works pretty nice. We have a pretty good documentation. And obviously, it was designed to be distributed and resilient to failure, which is standard in the cloud system. And it has a lot of awesome features. I'm not going to explain all of these features today because it would be way too long, but it does a lot of things. It's integrated with standard tools such as CollectD, Nagios, StatsD, Graphite, those kind of things. And it offers a REST API that you can work against. So I will show you just after. So what you need to do to learn to use Gnocchi and how does it work? So there's a few data type that you need to know about it. You will see in the API being used. So the metric, the orange one, is pretty obvious that these are the time series where you store the metrics in Gnocchi. So this is pretty easy to understand. In Gnocchi, everything is pre-aggregated. So everything, when you send metrics to the database, to Gnocchi, is going to compute things like the minimum, the maximum, the average, all these kind of things in advance. So when you want to retrieve them, it's very fast to retrieve them, which is something that we needed because waiting for minutes to do the computation each time you want to draw a chart on the screen is not something that is very useful. So, and how you control this aggregation is defined by the archive policies. So in an archive policy, you're going to set, well, I want to compute the average, the minimum, the maximum, all these kind of things, or the percentile, and I want to keep the data for a year, for example, and I want to do this kind of aggregation every 5 minutes, every hour, or every day, or whatever. So you configure this in archive policies. All of these data model here can be manipulated using the API, the REST API. And all of these metrics where you store your data, it's not really obvious how to retrieve them. Like when you measure a lot of things, let's say a few hundred, a few thousands of virtual machines, you have a lot of time series stored in the database. But you want a way to organize them, to query them, to find them again. So what we did is to create resources. So resources, it's exactly like classes in Python. We have resource type where you declare type of resource, for example, an instance, a virtual machines. You declare attributes like the host it's running on, the flavor, these kind of things, and you can instantiate them as a resource, and you can link metrics against them. So, for example, you can call a metric a CPU, memory usage, or if your resource is an application, you can have a metric which is the number of visitors. And all of this is stored into an index. So the index is in charge of keeping those relationships that I drew just on the slide before in a storage system. So we have 3 storage systems in Gnocchi. This is the architecture. It's not really oversimplified. It's actually how it works. It's pretty simple. So you have the users talking to the API, which is a REST API. It's nothing very complicated. And when you send measure, they are going to be stored in a temporary storage, which we call the measure storage. It's usually the same one that the metric storage, but it can be different. And you have another process which is called metric D. So you just have to follow the red arrows here. And the metric D process is in charge of getting these new measures out of the storage, compute the new aggregation, the new average, the new minimum, the new maximum, for each of the guarantee you configure in the archive policies, and store them back into the metric storage. So the metric storage is a long-term storage. And all of this is stored in the index, which is the last piece of storage of Gnocchi. So we have 3 different storage, which are 3 different technologies behind. Why? Because, well, it's all different data model. Having everything stored, for example, in SQL will not work. Storing millions of points of timestamps in a table in SQL is not really an option and not really scalable. Metric D itself, so both the API and metric D, the daemon doing the computation, are scalable. You can run any amount of daemon that you want and you need. And they're all coordinated with something that we call a coordinator, which I'll talk just after, which is also something we built in Python to help us. So the different storage, the index is currently, it's a driver system, so if you saw the talk just before mine, which was talking about decoupling, we do a lot of that in OpenStack in general, like we did that in Gnocchi, so everything is driver-based, so we have a driver for the index storage, and it's currently, the only driver is a driver with SQL Alchemy. We do leverage a lot of features in PostgreSQL, so we do recommend that one, but it also works with MySQL. And the storage for measures is either plain files, if you don't need any scalability, or Ceph, which is our best storage driver because Ceph offers the best performances for storage. And we also have Swift, which is an object store equivalent to S3 at Amazon that we do know how to use too. Very less efficient, but they do work well also, and very, very scalable. You can store hundreds of terabytes on those kind of storage. We have two magic libraries that we use in Gnocchi. So the first one is Carbonara. It's not right now a standalone library. It's a library that is embedded in Gnocchi for now because the API changes a lot. It's based on Pandas and NumPy. So we started with Pandas a couple of years ago, which is very good because it's very easy to write any kind of statistics, any kind of computing you want on your time series, but it's very slow. It's very, very slow. When metric D, the human responsible for doing the computation, does a lot of this kind of computation over and over again, and using Pandas is quite slow. So we're slowly rewriting the part of Pandas that we use in Carbonara using NumPy, which is way faster. But it's a very good start. I mean, having Pandas helps us a lot, having something working from the beginning. And we also use another library that we created a couple of years ago, and it's Choose. So Choose is again an abstraction layer. We do love that against all of kind of things, MMCached, Zookeeper, SQL, etcd. So it provides two things. First, it's a distributed log management. So it does not provide itself the distributed log, but it can leverage MMCached or Zookeeper or etcd or whatever. Even MySQL works for doing a GLM, distributed log. So you don't have to when we created Gnocchi, we had, for the coordinator part that I showed earlier, we need a distributed log, just to say, oh, I'm working on this metric, and I need to log this metric for a while during the computation. And we had the option to depend on something like Zookeeper, which is pretty resilient, scalable. But if you say to users and operators deploying software that you want to depend on Zookeeper, they're not going to install your software because they don't want to run Zookeeper. There are a few operators that will be happy to run Zookeeper because they already have a cluster system using it, but most of the time they don't want to use it. And same goes for the developers. If you say to them, well, you want to test your software, I mean, you want to test Gnocchi, well, you need to deploy Zookeeper on your laptop, they're not going to be happy. So we have this abstraction layer tools, which allows us to configure dynamically in the software. Well, I have a Zookeeper available, so that's pretty solid for production use, and you can use it. But if you don't have Zookeeper, you can just spawn memcached and it will work the same way. You can actually write a pretty poor distributed log in memcached. It also provides another set of primitive, which is the group membership. So that's pretty helpful to actually manage a group of processes in Python. If you have a group of processes spread across a lot of nodes doing computation of things or distributing jobs, particularly. If you have jobs you want to distribute across a lot of processes, across a lot of nodes, tools can help you with that. So it works with a lot of other drivers like memcached, same thing, Zookeeper, or it doesn't work in MySQL or PostgreSQL yet, but it's pretty easy to have groups of nodes to do the same thing and distribute it. So now, how to use it? So it's pretty easy. You can use pip to install it, so there's a server and a client. We use a flavor system in pip to deploy it, so you can You can, between the brackets, say which driver you want to use, which will install the right dependency, so it won't install all the dependencies. So Gnocchi bracket file PostgreSQL is going to install the file driver dependencies and the PostgreSQL dependencies. The client, you just have to edit the configuration file where you have to change like a couple of lines only because everything works by default. The upgrade script creates the first data in the SQL database. And then you have only 2 daemons to run, and you can run any amount of worker for these daemons on any number of nodes, which is the REST API and the metric daemon. Once you've done that, you can use, so the stage is pretty small, sorry, but there's a lot of outputs, so you can use the Gnocchi command line tool to, the first command is Gnocchi archive policy list. So this one just lists the archive policies. So there's 3 by default with less or more or less retention based on what you need. And on the right, you can see the execution methods which are used, like standard deviation, number of points, 95 percentile, minimum, maximum, etc. The second command is Gnocchi metric create -- archive policy name low. So that's just used to create a new metric. So once you do that, you have a new metric with ID is just there. So it's a UUID, which is created for you by Gnocchi, and you can use this UUID here to just run a bunch of measures. So that's what this command does here. It's adds measure. Here you have the timestamp and the values to this UUID just before, and then you can request to show the measure, and you see here that by default return the average. So the average has been computed for the whole day here, for the whole hour, and for the 2 5-minute slots that we sent here. Same thing, you can record here the minimum. So the smallest value is 22, which is there too, so it works. 42 is the minimum interval for this 5 minutes here. It's this point here, so that works. And it also computes percentile, so if you do network stuff, it's useful most of the time. Network people love to have 95 percentiles. As I said, all these kind of metrics, they can be pretty hard to retrieve or to organize. So we have our resource system here. What we do is we create a resource type. Here, there's a basic resource type, which is called generic, that we can use. It's like the object class in Python. It's just a standard object. Here I create a server resource with 2 attributes, a name, which is a string, and a host, which is a string too. I'm going to create here a resource whose name is ww42. The host, it's hosted on, it's compute1, and 2 metrics, CPU and memory. The type is a server, which is the type I created here. And I'm going to generate here a UUID, because you can pick the UUID you want for your resources. So UUID of the metrics are created directly by Gnocchi. For the resources, you can supply your own ID, which is useful if your objects already have IDs in an outside system. And here it returns the object it had created. Then you can obviously update the resource. So that happens a lot, for example, in the cloud computing system, is that when you create an instance, you have to move it at some point to another host. That happens a lot. So in this example, it's what I've done. I change the attribute host from compute1 to compute2, saying, oh, the server has moved to another computer, so the attribute here is updated. And I can then retrieve the history of the resource. So I have a whole timeline of the history, which is stored here. It's in this case, I asked in a JSON format, and I just have here the first as compute1. I have the revision end and start, which indicates at which part of the timeline this object exists. Same thing here. It changed to compute2 at this time here. So I can retrieve the whole history of a resource object, which is pretty handy. Since my object has metrics attached to it, I created 2 metrics, CPU and memory. I can directly send metrics measures to the CPU of this resource here. And same thing, I can show this value back, which are shown here. Like I said, there's a lot of features, so obviously we have a database with all of this information in it, and you can do any kind of lookup. I'm doing a simple search based on the host. Those are all the servers that run on compute too, and I do it with my server here. You can do any kind of query in the history of the resources too. You can do search in the metric value too, so if you want to retrieve the list of servers that use too much CPU, you can just send a query to Gnocchi to retrieve it. It's not tied to only infrastructure, so in our context in OpenStack we do talk a lot about instances, volumes, and networks, but it's actually applicable to any kind of resources. If you have an application, a website with visitors or anything, you can use all this system to create your own metrics. So this is how to use it in Python, so it's pretty simple. You just have to use the SDK, which is Gnocchi client, which is on PyPI. First thing, you create a client, so specifying the URL of the API, and then you can create a metric with just one call, add a measure, add a resource, create a resource here, and here I just created a generic resource, which exists by default, so it does not have any attributes, just an ID. I used a string here, a matrix, the number of visitors, and I'm going to send the number of visitors for these different timestamps. And I can retrieve them here, and it will return the list of metrics. So I just sent a couple of metrics here, and I retrieve them here. And the equivalent Gnocchi client command is just here. It has Grafana support, so I'm not sure you can see it, but it's Grafana. We have a plugin in Grafana, which is pretty easy to install from the Grafana repository, and you can plug to Gnocchi data source in just a few clicks and build a dashboard to show any kind of metrics that you have in your infrastructure or application. So that's it. We have pretty good documentation on Gnocchi.xyz. It's hard to find TLD these days. And we have a IRC channel if you want to hang out and ask any question. And that's it. Thanks.